Okay, let's start with the first problem in this graded homework 2 here. So this is given the following balanced equation, determine the rate of the reaction with respect to SO3. So this is about stoichiometry, and I wanted you to think about as O2, for example, disappears. So I have a pile of O2, and I take away 1 scoop from that. I'm going to get 2 scoops of SO3 that appear, because that's what the stoichiometry says. So in this particular case, the rate of appearance, that's what it asks for. It asks for determine the rate of reaction for SO3. And from the balanced equation, that's going to show it's going to appear twice as fast. So we have to take the change in the concentration of SO3 per unit time, change in time, and multiply that by 1/2. So that's what's down here. Now it's positive because it's appearing, so that's the answer down here, positive. The other option was negative. Those are really tiny. You got to see those, positive and negative. This is a positive, and that's question 1. And here is question 2 then, and it's really the same question as number 1. The reaction here is 2 HBr, so 2 of these gives 1 H2, and then it tells us the rate of disappearance of HBr is 0.11 molar per second. That is 2 of those are going to go away to form 1 of these. So that means that the rate of disappearance is going to be twice as fast for HBr as it is for the appearance of H2. So it's going to be 1/2 of whatever this stated rate is. That's 0.111. Multiply that by 1/2 or take half of that, and you get this 0.055. So think about pile of HBr, taking 2 scoops to give 1 scoop of this, so the rate of appearance of H2 is going to be half as fast. So here's the third question. Now you want to look at this and look at what the data you're given, and then what's the question that's asked. So it's determine the rate law and then calculate the value of K. So to determine the rate law, we now know 2 ways to do that. One is the method of initial rates, and the other one is using the integrated rate law and plotting the data to see if there's a straight line for a given way we've plotted that data. Now this is given initial rates. It tells us the starting concentration of the N2O5, and it tells us what the initial rate is. And so the way I answer this question quickly is that I look at these two, looked at 0.084 as our starting concentration and 0.224, found out what that's a multiple of, and then I'll just work through the problem. I'll show you how I do that. So it's 0.084 and 0.224. So in this one I took 0.224, and that's molar, 0.082, I believe what it was. Found out what that ratio is. It turns out that that's 2.67, okay? That's the ratio. So if I had rate is equal to the rate constant raised to the first power, when I change this value by this much, the rate should change by 2.67. If there's a 2 up there, it's going to be 2.67 squared. So then I go back and I look and see what the rates are that I'm given. And in this case, it is 4.37 times 10 to the minus 4th. 4.37 times 10 to the minus 4th. So I'm going to take my 2.67, multiply that by 4.37 times 10 to the minus 4th. And my number turns out to be exactly 1.16 times 10 to the minus 3rd, which is what the rate is for the 0.224. So it's exactly that ratio. That shows that's a first order reaction. Now what I have to do is solve for K. So I'm going to put in my rate that I calculate. So I can use either one, 0.082. That's my concentration, multiplied by K equals the rate, which I have to look up and see what it is, but then I just do algebra to solve for K. So that's all I need to do is solve for K to get my answer for the rate law and then the rate constant. And that's it for question 3.